You guys, Dan with Great Overland. We're excited to have you join us today. We're going to do a little behind the scenes and then come talk about some electrical systems. You're going to want to find out why Grit is beating everybody at their own game. Sorry about the noise. You're in a working shop currently. I wanted to point out this big storage cubby. You can see our breaker and fuse panels here, some access. Underneath that storage cubby is where all of our electrical is housed. That is a way smaller footprint than what other van companies are doing. If you look around in other adventure vans, there's no storage back here. Let me show you why this is possible. It's the difference between 12 volts and the big battery bank that everybody's putting in our competitors' vans, that 51 volt battery bank. Let's go to the front and we're going to talk about why this is. Trust me, you're going to want to watch this video if you've been researching camper vans. It makes a difference in the future of your adventures. Okay, you guys, if you're new to batteries, you're new to looking at this stuff, this may feel a little confusing at the beginning because we're going to talk about two different voltages. Really, if you are thinking about voltage and you're thinking about battery and energy storage, watt hours is the king. We typically tend to, if you've been researching, you may be familiar with this battery. It's a Battle-Born 100 amp hour battery, excellent battery. But really what we want to think about is 100 amp hours. That's good, an understanding, but what that doesn't translate well to is this is a 12 volt battery. This right here is a Lithionics 51 volt battery. It's just a blank. It's for mocking things up. But as you can see, the storage capability is very different, but the amp hours changes based on the voltage. So we're going to talk in watt hours today. Essentially, what you should know is a 300 amp hour battery is about 4,000 watt hours. So this is a Lithionics Boss battery, a Boss 302. It's 310 amp hours, 320-ish amp hours. But throwing all that away, it holds 4,000 watt hours. Okay, this is 1/3 of that. So it's about 1,250 watt hours. This is 8,400 watt hours, but it's 51 volts. So it can charge a little faster. What I want to do is we're going to come over here to the grease board and we're going to talk through this process. And I want to talk through what Grit is doing and simplifying and making super usable for you. And then what our competitors are doing in some of these new 51 volt vans and why it's not better. 12 volts has been around since 1955. 51 volts has been around for a long time, but new to vans, and there's some problems in it that you should go in with your eyes wide open. So what I'm going to do first is I'm going to lay out a simple 12 volt system, which is what we do at Grit. And the reason it works is because of the Ford Transit that we ordered direct from Ford Factory. Comes with 2 alternators. Bear with me here because I'm not a good artist, but I want you to see this because it'll make a lot of sense after you see this, and you can start having making educated decisions about what is important to you, what isn't important to you. The first thing I want to point out is size matters. Obviously, we all know that in batteries. But the only reason size matters in batteries for the most part is if you're trying to run an air conditioner off-grid. That is why all of these companies are going to really big battery banks and 51 volts. They need to recharge that battery fast, and 51 volts allows that so that they can run the air conditioner off-grid. There are some inherent problems with that, and we're going to get into that on the 51 volt side. They're all using essentially the same system. I helped design it, so I know what they're using. And then we have created a similar system, but all 12 volts and simplified. The way that I want to start is from the end in mind, and that is the point of a battery bank is to run all of your systems. And really, you can run most systems with a very simple, low energy storage, small lithium footprint until you add in that air conditioner. When you add in that air conditioner, it changes the game. You need more energy storage and you need to be able to recharge fast. Otherwise, it's not helpful because you can only run that air conditioner one time and then you're recharging for hours and hours. So this is how we did this. Our focus was on really good cooling capacity in your van, but limiting failure points and limiting frustrations for you as a user. So in our Ford Transit, the Link 148, you've got 2 alternators. I know, it's excellent art. I told you. So we're going to call that an alternator, and we'll just put an A next to it. Okay. Our vans come stock with 2 alternators from Ford. Why is that important? Because they're both Ford factory alternators. We don't have to worry about controlling them. They're pushing off, each one of them is a 250 amp alternator, so they're capable of pushing off 500 amps. We're not going to take anywhere near 500 amps. We're actually pulling 200 amps, and the system can handle it really easy. And then in the engine compartment, if you ever have a problem and you take it into Ford to be serviced, guess what? They look at it and they go, oh, these are all Ford parts, no problem. There's a couple of ways that your battery bank will charge. So in this case, we're going to start with alternator, and then we'll talk about solar and shore power afterward. This then travels down a cable to your battery. You got your positive and your negative battery terminals there. What we use in our van is a Lithionics Boss 302. It's 320 amp hours. I'm going to go back to watt hours. It's 4,000 watt hours of storage. Then, still, 12 volt alternators, 12 volt battery bank. And then when you want to use your air conditioner and all of your appliances, they're all 12 volts except for using the inverter. But this is the big thing, right? Having a big battery bank is about running an air conditioner, not everything else. Everything else pretty much can run on a couple of 100 amp hours, so 200 amp hours of battery. So what we've done is we did a 12 volt air conditioner. This 12 volt air conditioner that we use is very efficient. You haven't changed energy storage type in any way. You haven't converted, you haven't inverted, right? And so you've got a really clean stream of energy that's very efficient and very simplified. And if you watch some of our other videos, you've seen the way that we keep the climate control really good in that van, and we make this really simple 12 volt air conditioner very, very functional, is by insulating the crap out of that van. So this is only a 6,800 BTU air conditioner. Everybody in this industry is putting in the Coleman Mach AC unit. It's like 13,000 BTU, but you've got to run it through an inverter to use it. So super simple. 12 volt alternators that are stock from Ford, 12 volt power, battery storage lithium, small footprint. Again, that footprint is just that little battery, and I'm going to grab it and hold it up so you can see how small it is. This is a blank, right? So it's lightweight, but this thing weighs like, I think it's like 55 pounds basically is what this ends up weighing. So it's a very small footprint, which remember in the van a few minutes ago, that is why we're able to put so much storage up above it for cubbies and gear storage in the gear garage. Small footprint. This one little battery, and this is the question you guys are most likely gonna ask me, how long can it run that air conditioner? It will run that air conditioner on high, 5 to 6 hours, depending on how hot it is outside. On low, on eco mode, it will run it for 15 to 16 hours off of one charge of this battery. Here's the great thing, and I'm gonna draw this up for you here. So, on high, say 5 hours, and then on eco, 15 hours. Okay, that is your runtime. Well, the big question is, how long does it take to recharge this battery to be able to continue running that thing? This is where the next charging sources come in as well. So if you're just using the alternator system, we're actually charging at 200 amps an hour, which is about 3,000 watts. So we're recharging that whole battery bank, and you're never going to use all of it because it has a shutoff at 10% to protect the battery from going too low a voltage, in about 70 minutes. So you turn your van on, you let it idle for an hour, and then basically that whole battery bank is recharged in about 70 minutes. Okay? Remember, very, very simple. One cable running back here, or two cables, a positive and a negative, all 12 volts, all 12 volts back to the air conditioner. What we haven't even talked about yet is the other ways that this system charges. You've also got solar. And you also have shore power. Okay? What cannot happen in this 51 volts that everybody sees is you can't put enough solar in a realistic way on top of a van to actually charge 51 volt system. And we'll talk about that in just a minute. But basically, the solar panels that this van comes stock with is 180 watts of ZAMP solar, and those 180 watts actually make a difference. If you go one step further and you add the Link 148 is already plumbed for a second set of solar panels. So you can actually put a total of 360 watts of solar on top of a Link 148 on eco mode in a sunny day, real world scenario. It will 100% offset that the pull of the energy of that air conditioner to keep your van cool. Real world scenario, last year when we were testing this system, it was 92 degrees in Santa Rosa. We were at a van show, and if you've seen some of our other videos, you may have heard this discussion a little bit. We had the slider door open, and we had one of the back doors open because we're at a van show showing the van. Put all the window covers up. We turned the van on, blasted the Ford Transit air conditioner, cooled the van down, kept the window covers up, but then opened the slider door and opened up one of the back doors because we're still having customers come through the van. It kept the van 75 degrees with two doors open while running on eco mode, and 360 watts of solar offset the entire draw of that air conditioner. The point of sharing this is you do not need to get crazy and have a 51 volt system in order to have a very, very functional off-grid air conditioner. This is huge. Why is this huge? Because the price tag for that 51 volt system pushes the van cost $40,000 more expensive. Okay, we don't have to get into the numbers. What we want you to do is jump on our website, call us, we'll give more in-depth explanation about this, post questions. And we're gonna run through the 51 volt system here briefly. Obviously, most of us know what shore power is, that's plugging in. But what we found is almost none of our owners that have the Link use it because they don't need to. Because you spend a couple $1,000 on adding extra solar with all the bracketry and everything. I think it's like $1,800. But now you're offsetting your AC use in a major way. You're trickle charging your main battery, and then you're pulling 200 amps, which really recharges this whole battery in 70 minutes of idling. You do not have to be driving. One other thing I'd like to point out, Ford versus Mercedes, and this isn't just Ford versus Mercedes, it's gas engine versus diesel engine. When you idle a diesel engine, which is what this system has to do to recharge, and we're going to talk about that, on all of our competitor vans, they're all building on the Mercedes chassis. When you idle it, it fills up the diesel particulate filter, and it causes codes and problems and all that stuff. Back when those vans used to be straight piped and have no DEF system, it was great. You could idle it all day, no big deal, didn't cause any problems. Now you're having to go into Mercedes, it's having to be serviced more often, it's filling that filter up, and it's causing tons of problems because you're recirculating all of that stuff that's not designed to be recirculated into that system. So if you have questions, throw them in the comments section, follow us, give us a call actually, and we'll talk you through more of this. And even better, come visit us. If you decide to buy a Link van, we'll give you like $750 paying for your plane tickets if you buy it toward your van. Now let's talk our competitors. The one thing I want to point out is there's minimal failure points here, right? You're talking about a simple 2-aught cable, big cable, running from your alternator to your battery, simple cables to your solar, everything's fused, normal stuff. Again, I'll remind you, 12 volts has been around since the 1950s. It's tried and true. It's in every vehicle. It's simple. We can ground to the chassis easily. Minimal failure points. That's the end goal. This system should be usable and easy, and fade into the background so that your adventure is the focus, not your van. Now let's talk 51 volts. Okay, you guys, now 51 volts. You've got the attempt at charging in 3 different ways, right? Van charging is focused on 3 things. 1, off an alternator. 2, off of solar. And 3, off of shore power. Okay? Let's talk about how those 3 charging sources play into 51 volts. First of all, in your engine bay, the Mercedes comes with a single alternator, which means you've got to add a secondary alternator from another company, not Mercedes or Ford or whatever van they're putting it in, but typically this isn't a Mercedes chassis if you're looking at major competitors in this industry. So you've got a secondary alternator. Now that has cables that run back to your fuse block and to your battery system. We'll keep it really simple here. Again, not an artist. But you have a secondary line that comes back. That goes to a controller, which then tells your battery how quickly to charge. Essentially, this is how communication happens in this 51 volt system. You've got an alternator that is a secondary alternator, not stock Mercedes. So if you ever have a problem and you take the van in, we've personally experienced this. Some Mercedes dealerships are good with it and they go, oh yeah, no big deal, not a problem. Others are like, we don't want to touch it. We don't want to deal with it, which is why on our grit system, we started buying 2 alternators right from the factory from Ford. The second problem you have, it goes to a controller, which controls the alternator and the charge, the heat, it monitors the temperature and everything of that alternator. Then that has to communicate with your battery management system. It's basically the brain for your battery. In our system, or that simple 12 volt system, that brain is all inside the battery. It's all in there, keeps it really simple, very few failure points. On the 51 volt system, it's external. It has to be because of the nature of how this thing works. So now you've got failure point, and then that battery management system, or the brain of that charges the battery, has another failure point. So you've got a system. Here's the other thing is mostly those are from different companies. So now you're asking like devices from 3 or 4 different companies to talk perfectly every time. Inherently, it doesn't fail all the time. It's a great system when it works right. But inherently, the nature of that is more complicated, which can lead to more failures over time. Now let's talk solar. So solar by nature in the van industry has been thought of as at the very beginning from like, yes, my solar is going to charge my whole battery. It's not really how it works. It's more of a trickle charger. And the tech isn't there really to charge 51 volts. So here's what people are actually doing in their vans. And this is all the major manufacturers. It doesn't matter which one it is. If it has a 51 volt system, solar is not charging the 51 volt battery. They're actually taking those tiny solar panels that they're putting in that van, and they are charging the starter battery. And that starter battery, the reason they're doing that is because in the Mercedes, they die all the time. It's just an inherent problem of the way that they do the system. It wakes itself up, it does its diagnostics, and then the battery dies, which is why there's multiple different devices, solar panels for the hood, designed to trickle charge that starter battery. So all of those manufacturers are not charging their 51 volt system because you cannot put enough solar on top of a van. For the most part, there's a few people that have been very creative with huge systems and it works, but it's really complicated and very expensive. And the solution is very simple if you go back to 12 volts. So that solar is trickle charging your starter battery. It's not even charging the 51 volts. In some of the vans, they've added an extra little line that maybe runs to the refrigerator, which is kind of cool, but it's not charging anything in a major way. The other thing, again, going back to it is, in this system, you still have to idle the van in order to charge it in a major way. And I'm gonna get rid of this solar out of here for a second. And the whole purpose of this discussion is, let's talk about the air conditioner, right? That's the whole point of having this 51 volt system, is you can run your air conditioner off grid for 11 to 13 hours and then hopefully recharge this battery very quick if you don't have any of these failure points. Again, I'm not gonna say it fails every time. We helped design a system that worked very well. What we found is it just has some issues that are complicated, and that's why we went back to the drawing board and figured out how to solve it with a 12 volt system and more insulation for climate control. So here's what our competitors are doing and the industry is doing. They're taking a 51 volt system that they're charging off of this new 51 volt alternator. So it's a 51 volt alternator. It's running the signal through all these complicated controllers and BMSs to a 51 volt battery. And then they're taking that 51 volt battery and they're running it to an inverter. If you're not familiar with this, what the inverter does is it takes those 51 volts and turns it into 110 volts like your house. And here's where the big problem is. In that space between there is you waste energy. It's like around 18 to 20% of your energy goes to just inverting from DC to AC, which is direct current to alternating current. It's really complicated in the back end, but what you guys should know is they're taking that, you're losing about 18% to 20%, depending on the quality of the inverter, that you don't even see go away. And then they're running that into a 110 volt air conditioner. So that 110 volt air conditioner is very inefficient. It's big and it puts out a bunch of cold air. And it's typically 13,000 BTU. It's a rooftop AC. The typical one is the Coleman Mach. There's a couple of other brands. They all do similar work. Here's the big problem. A byproduct of inverting energy from DC to 110 volts, DC to AC, is heat, right? So you're giving off heat when you invert. Then this air conditioner is pushing a bunch of energy. It's using all that energy up. It's inefficient, and it's using up an extra 18%. So now what are you having to do? You're having to fight the heat that you're pushing into the cabin, running it through the inverter, when in reality, all you had to do is get rid of your flares or your sleep pods where you're sleeping sideways and put in more insulation, and all of a sudden a 12 volt air conditioner works very well. So with this big AC, it's pulling a bunch of energy and using up all of this battery bank that's huge. By the way, again, I pointed out that our battery bank is 4,000 watt hours. The battery bank that's going into most of these other vans is 10 to 13,000 watt hours. Okay, 10 to 13,000 watt hours is what they're actually putting in here. It is double to triple the lithium footprint and still not as effective because they haven't insulated the vans. They haven't gotten rid of the sleep pods. This is where our north-south bed comes into play. And I'm gonna grab our display and I'll show you what I'm talking about. But you guys, if you have comments on this, throw it in the comments. If you have questions, either give us a call. We'd love to talk to you about it directly. And it's not us talking trash about this. You guys should go in with your eyes wide open. I wanted to give some free education on this because it's really complicated and it's not the best solution. And again, what I'm going to point out is the whole point of this is this AC unit is like a $900 air conditioner. And they're using this $40,000 electrical system so that they can use an $800 or $900 air conditioner instead of just spending the money on a 12 volt air conditioner, using a nicer air conditioner and insulating the van better. Let me show you what I mean. Before we actually get into the insulation, I want to show you guys one more thing related to this. This is what we're running that air conditioner for 15 hours on eco mode. And on eco mode, because of the way we insulate, it will actually keep the van nice and cool. This is 8,400 watt hours. So 8,400 watt hours. This is about what the other competitor vans are putting in that are on the market. Most of them are putting in 10 to 13,000 watt hours just to run that little 110 volt air conditioner that's like $800 or $900. And they have to do that because they're not insulating well enough, so they're sleeping sideways, and those sleep pods on the side of the van are only 1/4 inch thick fiberglass. So that 1/4 inch thick fiberglass, if it's in the summertime, you're blowing all that air conditioner into that space, and it's just dumping cold air out of the van through transfer. And in the wintertime, it's letting cold air in, and all of your heat is going out through that space. So this footprint, compared to this, actually their battery bank is bigger. It's another couple inches bigger. But going to a smaller footprint means we're pulling less lithium and cobalt out of the earth. We're doing less damage to the earth. Reality is lithium's not great, but it's the best energy storage we have right now, and it recharges quickly. But going to this smaller footprint allows us to have all of that extra storage in the gear garage. And this is what all makes it possible. You guys are going to laugh because it's the simplest, cheapest thing to actually do in a van. This is a cross section of our insulation layers of what we're doing. So on this side, we have a double layer of closed cell foam, hydrophobic, so it's not going to absorb water. It's antimicrobial. It's not going to mold or any of that stuff because it's all synthetic. The first layer helps to noise dampen and to minimize conduction of heat and cold in and out of the van. And then the second layer helps to minimize radiation because it's got Mylar on both sides. So you're going to get less radiating heat coming through the van when it's really hot and sunny outside and it's heating up the outside, the exterior of the van. But this is really the money right here. In here also you've got our aluminum infrastructure that we do and our wall panel. But this is what actually makes this all possible. We take advantage, and this is 2 reasons that this works. One, the Ford Transit has deeper walls naturally than the Mercedes. The Mercedes has about 2.5 inches of space between the inner framing and the outer skin of the van. The Ford Transit has about 5 inches in most spaces because it's taller inside and they give you more space in that wall. So in all areas, it's getting at least 1 layer. In most areas, we're putting in 2 layers of this 600 mil Thinsulate. And then around the bed, where the AC is, we're actually putting in 3 full layers. We figured out the R value the other day. It's actually about an R value of 15, which is why we can take that little 12 volt air conditioner that does 6,800 BTU and cool down that entire van and keep it nice and cool, and then have that much smaller lithium footprint in there, which is better for the earth. It's better for the consumer because there's less problems with it, less parts that can break in a 12 volt system. And then also you gain more storage on the back end. All to throw that in there, you guys, you're also talking about a $35,000 to $40,000 price difference because the electrical system is less complicated. We're not having to put in all these extra controllers, all the extra BMS, and all of the extra alternators and stuff. It's just coming straight from the factory like that, which makes your maintenance less problematic when you do have something that is wrong. You guys, I hope this is helpful. Share this with people who are doing research because this is a big deal. This is stuff you should know before you go buy a camper van or you do your van DIY, whichever that is. Again, if you have comments or questions, throw them in the comment section. We will reply to you. If you want to see a video on something else describing something different or more information on something, we're happy to do that. We want to give out good information. We want to educate because we believe that what we have in our product is amazing and it's making people's lives better every day.